Today, we're the only human species on Earth. That seems completely normal to us. But in fact, it's highly exceptional. As recently as 50,000 years ago, a blink of an eye on the scale of human history, Homo sapiens was just one of many species of humans.
We are aware that we are the only ones, so imagine different species would be around. It is a very difficult intellectual exercise, I think.
The big question for us is, what did they do when they meet? And why did all these meetings in the end lead to the other groups disappearing and only us surviving?
One of these extinct species hold the deepest mystery, the Neanderthals. They're our closest cousins and were the undisputed rulers of Europe for hundreds of thousands of years, until our ancestors Homo sapiens came along.
So there's been a big debate about what the blame for this disappearance. Did they become extinct because of Homo sapiens?
Now, alongside leading researchers, we'll follow every clue and compare the two species' strengths and weaknesses by virtually resurrecting the last Neanderthal.
So by looking inside the fossil, it gives you much more information than earlier researchers had.
We'll also explore how the Neanderthals lived and hunted, their relationships with other clans, and their abilities as a group.
They went for the most dangerous animals. Neanderthals obviously hunted for prestige reasons.
From Spain to the Altai Mountains, we'll try to crack the Neanderthals' genetic code, hoping to understand one vital question: why did we survive when they did not?
The question is why Homo sapiens were so successful. That's what it comes down to.
This was a massive breakthrough in our understanding, not just of the disappearance of Neanderthals, but who we are.
This sweeping investigation, spanning hundreds of thousands of years and 3 continents, will shine a new light on humanity's most fascinating enigma. West Germany, the Neander Valley, or Neanderthal in German. Here, a discovery would change everything we thought we knew about human evolution. In 1856, a group of miners stumbled upon a very old, strangely shaped piece of skull. It looked human, but its brow bones were much more pronounced than ours.
People started claiming that the Neanderthal was some kind of missing link between the apes and us, Homo sapiens. In addition, because the discovery was made in the 19th century, a colonial era, there was this idea of a hierarchy of humans through colonialism. So inevitably, this Neanderthal with its particular head shape was thought to be different from us and inferior to us.
But who were the Neanderthals, and were they really inferior to us? At the Institute of Human Paleontology in Paris, a sculpture from the beginning of the 20th century shows us how they've long been imagined as a cross between human and ape, aerial and bestial.
They're represented as a great ape with a small club, or sometimes a small pebble in their hand. That's the most common image, regardless of the author or sculptor, that of an ape man.
Neanderthals are just seen as cavemen, so you just have these images of them in a leopard skin suit and bashing the woman on the head and dragging her to a cave. I'd still remember that image of when I was a kid, of what I learned about Neanderthals.
This image of Neanderthals is found everywhere, that of a mean, brutish, slightly stupid, and violent creature. The public often imagines them as our ancestors, a primitive form of humanity that preceded us and evolved less than us, as in this famous depiction of man gradually standing upright, which is common in popular culture.
Until about the 1960s, 1970s, we had a very linear view of human evolution, going from, Also with the idea that there was always only one species around. And so, the idea was modern humans evolved from Neanderthals.
But all of that has changed in recent decades. Since the first fossil was found in the Neander Valley, there have been numerous other archaeological discoveries. And we now know that the Neanderthals were not our ancestors. Over the past 2 million years, the evolution of mankind has not been linear, but more like a tree. From the same common ancestor, many different human species evolved in their own way. Neanderthals are therefore a human species in their own right that lived at the same time as our direct ancestors.
I think what's interesting about Neanderthals is that they are our closest extinct relatives. Like, there are lots of other hominin species around, but of all of these, Neanderthals seem to be the ones that are closest to us. They are the ones who share the most recent common ancestor with us.
500,000 years ago, our common ancestors lived in Africa. Part of that population had migrated to Europe, becoming Neanderthals, while the population that remained in Africa became Homo sapiens.
Homo sapiens and Neanderthals are two parallel evolutions in two different climates and two completely different regions. The Neanderthals were the indigenous form in Europe, while Homo sapiens evolved in Africa at the same time.
The two human species were separated for a long time, but that didn't last. There are more and more fossils of Homo sapiens in Europe starting around 45,000 years ago. At the same time, the Neanderthals were disappearing. It's hard to imagine this might have been a mere coincidence.
It's a question that has been asked from the beginning. We know that the Neanderthals disappeared at the same time as another species of humans started to appear in the same territory, that of Europe. We wonder how Homo sapiens' arrival might be connected to their disappearance.
Were we responsible for the disappearance of our closest cousin? Pandemic, genocide, technological domination? Every month, new hypotheses emerge in the media in an attempt to shed light on the Neanderthal enigma.
Oh, there's lots and lots of debate. Scientists love to disagree. So when there is a question like, why did Neanderthals disappear? Why are we the only ones who survived? People are going to come up with different hypotheses. And I think the problem is that, we always try to look for a simple explanation. And in reality, it's going to be much more complex.
To begin to unravel the mystery and understand how we might have been responsible, we must first determine when these events took place. Did the Neanderthals suddenly disappear as soon as the first Homo sapiens arrived? Or did the two species coexist for a while? In recent years, new dating methods have called everything into question.
Getting the right dates is super important because in archaeology, everything is about time and when things happened. In the last 10 years, there's been a real revolution in this, to get dates that are uncontaminated and precise enough to tell us the story of when Neanderthals disappeared.
Our investigation begins in Brussels, where one of the very last Neanderthals is kept. These bones are the remains of a man who was discovered at the end of the 19th century in the Spee Cave in Belgium. Their state of preservation is exceptional for such an ancient fossil.
People have this idea about fossils and skeletons, so they think, oh, a Neanderthal, and they think of a full Neanderthal. But actually, it's never found complete. So the Spee 2 is kind of an important fossil because it was almost complete.
It has long been known that the man of Spee was one of the last Neanderthals. But did he die before or after the arrival of Homo sapiens in Europe? Determining this date is essential. And Tom Higham has risen to the challenge using exceptional technology. At Oxford University, this gigantic 20-meter-long particle accelerator measures the amount of carbon-14 still present in the fossil. But in bones as old as the Neanderthals, there isn't much left.
Remember that Neanderthal disappearance takes place somewhere between, we thought, 30 to 60,000 years ago. And this is right at the point when radiocarbon becomes very, very difficult. The more carbon-14, the more recent something is. And the fewer carbon-14 atoms we measure, the older. So between the age of about 30,000 to 50,000 years ago, the amount of C14 is very low. It's less than 3%, because carbon-14 slowly decays through time.
Over thousands of years, tiny foreign particles mix with the fossils, further distorting the dating process. Tom Higham came up with an innovative solution to this problem.
The challenge of reliably radiocarbon dating the past is to remove contaminating carbon from the ancient bones that we analyze. So we use different chemical methods to do this, to get the right date.
Now it's time to let the particle accelerator do its job. The result is clear. The man of Spee lived about 40,000 years ago, when Homo sapiens had already been well established in Europe for a few thousand years. Tom Higham has studied 60 other Neanderthal sites, and all his dating confirms this new timeline.
We actually found that there'd been an overlap period of between 2,500 and 5,500 years, quite a long period in which Neanderthals and Homo sapiens were living in different parts of Europe at about the same time. Didn't just suddenly go extinct. Neanderthals and Homo sapiens coexisted for thousands of years.
The two human species managed to live together in Europe without causing the sudden disappearance of the Neanderthals, and this coexistence might have lasted even longer than previously thought. In 2022, the Mandarin Cave caused a sensation. Here in the Drôme region of France, archaeologists found a Homo sapiens baby tooth that dates back 54,000 years, 14,000 years before the death of the last Neanderthal. We must not imagine a single great wave of Homo sapiens sweeping across Europe. On the contrary, they had started settling there a long time ago, very gradually.
I don't think it's really that modern humans just killed off Neanderthals or completely outcompeted them. I think it was a longer process. And, you know, of course, there was also probably a geographic mosaic. In different areas of the world, it happened at different times.
If the hypothesis of an outright genocide is ruled out, what about the diseases that Homo sapiens might have brought with them? The disappearance of the Neanderthals is often compared to the colonialization of the Americas in the 16th century. In that era, up to 90% of Native Americans disappeared in just a few decades, due not only to genocide, but more importantly because of foreign viruses, such as smallpox, that were brought over by the conquistadors.
It's possible that locally there was violence, and there were also deaths caused by influenza or other viruses brought by Homo sapiens. But if it was truly an epidemic that killed everyone, the disappearance of the Neanderthals wouldn't have taken a few thousand years.
The investigation must therefore be continued. What happened during those thousands of years? And why did Homo sapiens survive while the Neanderthals didn't? What if the answer was simple? What if Homo sapiens were simply superior? In that case, it would be logical for us to win the great evolutionary race.
As soon as Neanderthals were discovered, it became apparent that they were considered to be the others, the other group, the ones that were not with us anymore, hadn't survived. And it's an easy argument to make that they didn't survive because they were less successful than us, less evolutionary advanced, simply because we're here and they're not.
As soon as the first fossil, that strange skull, was discovered, we quickly realized that the Neanderthals' bodies were different from our own. Could the secret of their disappearance be found within their skeleton itself? To find out, we'll go inside the body of the last remaining Neanderthal. Tara Chapman has accomplished a feat that has never been achieved before, creating a virtual reconstruction of the last Neanderthal by digitizing every single one of his bones.
Because obviously the fossils are very precious. There's just one of them, and if they're destroyed, that's the end of the fossil and the research. But this way, by taking scans of fossils, everybody can have access to it as well. So that can really help. You can have a hypothesis, and then someone else can look at that, and you can work together.
In recent years, advances in imaging techniques have revolutionized our knowledge of the Neanderthals. This CT scanner can distinguish details of less than 4 micrometers, making it 60 times more powerful than a normal medical scanner. And with this technology, everything can be observed, even things that are normally hidden.
Firstly, you can look inside the bones, which is super important, because unless you broke a bone in two, you couldn't look inside to see. For example, depending on how thick it is or not, you could say how much they did or how active they were.
Thanks to the 150 bones that have been digitized in collaboration with the Free University of Brussels, the skeleton of the last Neanderthal can now be brought back to life. Are there any signs of his inferiority? Might he have been weaker than us or perhaps less well adapted? To find out, we're going to explore every bit of his body and compare it to those of Homo sapiens.
In the global body size, they're really robust. Like, robust means kind of strong and stocky. You have very wide pelvises and a great big thorax. So overall, they are bigger.
Sapiens may have been the same size as Neanderthals, but they give the impression of being slender because the pelvis and the shoulders are narrower.
On average, Neanderthals were 10 centimeters shorter than Homo sapiens at the time, but the fact that they were short and stocky was actually a major advantage in Europe.
The short, stocky body shape of Neanderthals was an adaptation to the cold, which persisted for a very long time. It was a way of conserving body heat, because the taller you are, the more you disperse that heat.
Neanderthals were much better prepared than we were to face the ice ages, when the climate was hostile and glaciers covered all of northern Europe. That was not the case for Homo sapiens, whose anatomy was better suited to the warmer temperatures of Africa. What about their physical abilities? Let's go back to the Neanderthal body to take a closer look at their shoulder blades, which hold a striking clue.
There's a kind of large ridge on the Neanderthal scapula that shows that the muscles were not inserted in exactly the same place as in Homo sapiens. That has been explained as a muscle insertion that gave them a lot more power and stability for throwing movements.
And it's not just their shoulders. Neanderthals' muscle attachments are wider throughout the body in both men and women. Between Homo sapiens and Neanderthals, the Neanderthals had the larger muscles.
There's this question of what might have happened if and when they met. That was one of the hypotheses, that there might have been a clash between Homo sapiens and Neanderthals. When you see the differences in morphology between the two, it's not at all obvious whether Homo sapiens would have come out ahead.
In terms of power, Neanderthals are the clear winners. But beyond their anatomy, can we know what they really look like? Today, DNA analysis of fossils reveals previously unimaginable details such as skin, eye, and hair color. Surprisingly, here's what our Neanderthal couple might have looked like.
We've always imagined Neanderthals as being very hairy, with dark skin. In reality, Neanderthals were well adapted to northern climates. They had fair skin, light eyes, and hair that could range from red to light brown. On the other hand, the first studies and the studies done on ancient Homo sapiens reveal that they were real Africans, adapted to an African climate, so they had dark skin.
Nor should we be imagining the Neanderthals walking around naked all the time. Archaeologists have found marks on animal bones proving that Neanderthals harvest skin and fur with tools just as good as those made by Homo sapiens. Traces of ancient hearths have also been discovered, showing that Neanderthals had mastered fire.
That they were living in very, very challenging environmental and climatic periods where the climate shifted suddenly. So they had to cope with tremendous changes and adapt to those changes in order to survive, which they did successfully for, much longer than 250,000 years.
The mystery remains. While Homo sapiens might have lost from a physical perspective, perhaps their true power lays in their intelligence and technology. Were Homo sapiens better hunters? And would they have starved Neanderthals through more efficient hunting techniques? In 1996, in Schöningen, Germany, 8 spears were found in an exceptional state of preservation. They're 300,000 years old, making them the oldest weapons in human history.
These amazing wooden spears were previously, not considered to be possible to be made by groups like pre or Neanderthals, and yet they were making them.
These weapons are a testament to exceptional skill. They measure up to 2.3 meters long and are extremely thin, with a diameter of less than 3 centimeters. To be even more effective, their tips are fashioned from the trunk of a spruce tree, where the wood is the hardest.
These were extremely elaborate tools, made for a very specific purpose, which were designed with extremely complex operating chains. These tools show us that the Neanderthals were not simply more evolved monkeys, but that they had very strong cognitive abilities.
But how did the Neanderthals use these weapons? And what does that tell us about their hunting skills? In Germany, Sabine Gauduzinski reconstructed the scene. Her starting point? The bones of a 120-year-old fallow deer. They contain perforations previously unseen by archaeologists, which resemble the marks that would be left by a spear like the ones found at Schöningen.
The perforations we observed are characterized by particular breakage patterns that are very different from what we usually observe as a result of carnivore interference.
To test her theory, an experimental spear similar to the one found in Schöningen was connected to a computer. Each puncture was analyzed with a micro-CT scan and then compared with the deer's injury. Using this technique, Sabine Gauduzinski and her team were able to accurately reconstruct the angle at which the Neanderthals might have welded their spear to pierce the animal.
From these micro-CTs, it was apparent that the weapon that killed the animal was not thrown. They were used in basically confrontation and hunting.
But this technique is demanding. A single hunter couldn't have gotten that close to such a fast animal. It would have taken strategy and also the coordination action of a group, even more so for big game.
They hunted large animals. They hunted bison, aurochs, and even mammoths from time to time, all with spears. That requires proximity. It probably means that they had to be cunning, which is to say, they had to have a plan.
Neanderthals were not only powerful, they were also strategists, and their talents allowed them to face even the most monstrous of opponents. The straight-tusked elephant, a species now extinct that was then the largest mammal in Europe.
These animals were twice the size that we today see in African elephants. So, of course, they did not have natural enemies apart from humans.
Here we have reconstructed what such a hunting trip could have looked like. A dozen of the best hunters are mobilized. At the back, part of the group chases the elephant to tire it out and weaken it. Some of them scream to scare the animal, while others run alongside and weld their spears to trap the prey on the edge of the swamp. Until it falls.
When they fall on their side, they can't get back up. At that point, their entire abdomen is accessible, and you can easily finish them off. They use the environment as a natural trap to make it easier to capture the animals. That's very, very clever.
Sabine Gaudinsky has studied the carcasses of a 120-year-old straight-tusked elephant closely. These marks were left by a scraper, a stone tool that was used to skin the animal. The Neanderthals seem to have removed every single tiny piece of meat. The researchers estimate the amount of food to have been equivalent to more than 2,500 daily rations. That's far too much when you consider that a clan probably had no more than 30 individuals, and they couldn't keep the meat for long. So why take the risk of confronting such a monster?
If you're looking from a cost-benefit perspective, it doesn't make any sense. So unless you assume that social reasons played a major role here. So a huge number of people apparently came together in order to butcher the elephant together, in order to come together, do social things together.
We can imagine several clans meeting from time to time to create relationships, revealing a Neanderthal society that was much more structured than expected.
There was a social life, an intra and inter-community social life. It opens the door to types of behaviors that aren't just subsistence behaviors.
For today's humans, social connections are at the heart of our lives. Sociability is a major advantage. One human being on their own is fragile. It's when we are in a group that we become strong. For all human species, cooperation between different groups seem to have always been decisive for long-term survival.
It's also tempting to think that people were thinking similar ways back in the Paleolithic. When you're a hunter-gatherer living in a changing environment, you need people sometimes to help you, and group membership is a really important thing. And
might we be able to find the clues to this ability to socialize in our Neanderthal skeleton? Let's take a closer look at the inside of the throat. Archaeologists have proven that they had a very small bone similar to the one found in Homo sapiens, which is believed to be one of the secrets of spoken language.
We have evidence that Neanderthals had a hyoid bone, which is the bone in the larynx that we use to formulate sounds and to create vowels and so on. So we know that they were capable of making those kind of glottal, guttural speech noises.
The two species have a lot in common. Neanderthals were even more powerful and better adapted to the cold of the ice ages than Homo sapiens. So why weren't they the ones who survived until today? The disappearance of the Neanderthals is more mysterious than ever. But have they really disappeared? The question might seem absurd, but a sensational announcement has changed everything. In 2010, the team led by Savant Pabot at the Max Planck Institute finally succeeded in decoding Neanderthal DNA and comparing it to that of today's humans. The announcement caused a sensation. Most of humanity carries within it 1 to 4% Neanderthal DNA.
I think this really changed the view of everyone, especially to the public, learning that these cousins of ours, weren't just our distant cousins, but actually we carry a little bit of them in us today.
The beautiful thing I like is that because we all inherit Neanderthal DNA, that they're not completely disappeared. They're still with us. And that's a lovely thought, really, isn't it?
Faced with this result, there's only one possible explanation. Homo sapiens and Neanderthals mated. Save for the African population, we're almost all descended from that interbreeding. It was a bombshell for the world of science.
At that time, it was assumed by most of the researchers that really Neanderthals were a dead branch that didn't interact with modern humans at all. So I think it's clearly a change of paradigm, probably the most profound that has happened in the 21st century on human evolution, to understand that they had mixed, and not only once, but probably several times in several places.
One might think that this interbreeding happened at the time when Homo sapiens colonized Europe, but it actually happened much earlier than that, because there were also Neanderthals living in the Middle East.
All we see is that all modern humans across the globe outside of Africa today carry roughly the same amount of Neanderthal DNA, which to most of us indicates that this interbreeding likely happened soon after we left Africa.
Groups of Homo sapiens migrate out of Africa many times, more than 100,000 years before colonizing Europe. Along the way, they interbreeded with Neanderthals. Homo sapiens descended from these hybrids, then populated all the other continents, leading to our current population. But the first Homo sapiens pioneers weren't so lucky. On Mount Carmel in Israel, scientists have found both Neanderthal fossils and very old Homo sapiens fossils, some dating back as much as 170,000 years. And against all odds, these local populations of Homo sapiens seem to have disappeared without dissidence.
There had already been first contact between Homo sapiens and Neanderthals 170,000 years ago. But apparently, that contact was either unimportant or the contact took place, but it wasn't the Homo sapiens who won, it was the Neanderthals.
Maybe they spread just too far and they became isolated from one another and they disappeared. Maybe Homo sapiens encountered larger populations of Neanderthals in places like Europe and didn't move in. So it's very difficult to know.
Homo sapiens and Neanderthals sometimes coexisted in the same place for tens of thousands of years, and that encounter did not lead to the systematic extinction of the Neanderthals. On the contrary, in Israel, the Homo sapiens were the ones who disappeared.
It's not like we were destined to be the only ones left, but for pieces of luck, it may not have been us that was successful.
So what changed 40,000 years ago? Is it possible that the disappearance of the Neanderthals might have had nothing to do with us? Let's head to Asturias in the north of Spain. Archaeologists often find Neanderthal fossils in cave entrances where they took shelter. But this time, it was underground that the researchers made the most resounding discovery in recent years. There are no fewer than 3 kilometers of underground galleries and caverns here, which researchers have been carefully excavating since the 1990s.
I would say that is unique in the archaeological record because it's not a site where Neanderthals were living. It's just an underground karst system where Neanderthals fell from somewhere on top.
The remains of 12 Neanderthals have gradually been unearthed. There are 6 adults, 3 teenagers, and 3 young children. Thanks to the marks left on their skeletons, archaeologists have been able to reconstruct what had happened to them.
We speculate that in the surface, probably there was a rock shelter where other Neanderthals killed and ate the family of Elsidron. It's a bit the leftovers of a cannibalistic meal.
Cannibalism was common in some Neanderthal and ancient Homo sapiens societies. The reasons for this are still a mystery, with explanations ranging from funeral rites to pure and simple survival during great famines, as seems to have been the case in El Sidron.
I think it's just an expression of how harsh was living in Europe in those conditions, probably in winter. When they found another group, things could go from friendly interactions to just seeing the other group as a possibility of having, meal and surviving.
So might the Neanderthals have gone extinct because they all devoured one another? Researchers have ruled out this hypothesis, especially since the Neanderthals' way of life depended on maintaining a good relationship with neighboring clans. At the Institute of Evolutionary Biology in Barcelona, Carles Leluza Fox is trying to understand the social structure of Neanderthals by decoding the DNA of the El Cidrón 12. This is a once-in-a-lifetime opportunity. For the first time, the fossils of 12 members of the same clan have been found, all of whom died at the same time 49,000 years ago.
El Cidrón offered us the possibility of having a snapshot of the life of Neanderthals. Then, with genetics, we could try to understand the family relationships among these individuals.
Genetic decoding is an extremely delicate operation that begins in a high-containment laboratory. Here, the few pieces of DNA still preserved in the bones are extracted. But over 49,000 years, the DNA has deteriorated a lot. The samples must be decontaminated by removing anything that is not Neanderthal.
One of the sources of contamination is, of course, our DNA. This is difficult to understand, but we are losing DNA through the skin and hairs and breathing, etc. So in all ancient DNA labs, the people are trying to make it as much sterile as possible.
After sequencing, they can finally compare the genetic code of each of the 12 members of the clan. The 3 adult males are related. They appear to be brothers or cousins. Each of the 3 adult females, on the other hand, comes from a different lineage, showing that the group obeyed certain rules when it came to reproduction.
This is a suggestion that social structure was based on patrilineality, in the sense that the men remain in the same group where they are born, while the women are moved around different groups, so increasing the diversity of these groups.
Neanderthal clans met not only to hunt, but also to form new couples with women who changed clans to have children. The success of these one-off encounters was therefore decisive for the survival of the species.
You have to maintain genetic diversity, you have to maintain contacts. My thought is that if you've got these people living in small numbers across quite large geographic distances, what if it's very difficult to make those connections?
That's the question. What would become of the Neanderthal community that was isolated from its peers? To find out, let's travel 7,000 kilometers away to Russia, at the other end of Neanderthal territory. These are the Altai Mountains in Siberia, on the borders of Uzbekistan and Mongolia. Thanks to global warming, 130,000 years ago, Neanderthals colonized this land far from their native Europe.
I like to think about, the south of Siberia as a highway. You have these open steppes from Eastern Europe until, Kazakhstan, maybe even into Mongolia and China, where you can move relatively easily. The problem is that due to climatic fluctuations, this was frequently cut off when it became cold, and that's when they became isolated.
In the Chekaiskaya cave, archaeologists made a breakthrough that was decisive in understanding the fate of these Altai Neanderthals. Here, the remains of 11 individuals were found dating back 60,000 years. In 2022, the study of their DNA showed an extremely high degree of inbreeding.
This is a very, very small population that had extremely limited genetic exchange with anyone outside, and if you have a group of 20, 30 individuals that are primarily mating within this group, it's going to be complicated. There's not much mate choice. It's your cousin or you're alone for the rest of your life, which, is not a pleasant thought.
With such a high level of inbreeding, the genetic diversity of these Altai Neanderthals was extremely low, much more so than most animals on Earth. A similar level was found in mountain gorillas, an endangered species of which no more than 600 individuals remain on the entire planet.
Once a population gets to a certain small size, it actually can't recover because it just doesn't have enough genetic diversity. And because it means, for example, that you don't carry enough genetic variants that might allow you to adapt to changing circumstances, whether it's to climate changing, whether it's some pathogens coming in. If you have very low genetic diversity, you can't adapt to this.
Isolated from their peers, the Altai Neanderthals likely disappeared slowly over thousands of years, just like many other species in evolutionary history. But is Chagaskaya a special case, an exception because of its location at the extreme edge of Neanderthal territory? To find out, let's return to the El Sindron clan. Here, unlike in Chagaskaya, the women came from elsewhere, ensuring a certain amount of genetic mixing. However, analysis of the bones of the 12 individuals revealed some astonishing malinformations.
For instance, we have vertebra with cleft, we have atrophic ribs. We can have, I don't know, one of these traits in our body and having no harmful effects, let's say. So, but having 21 of them in all the 13 individuals is what makes a difference, I think, and what indicates that there is a consanguinity.
The problem of inbreeding was therefore not limited to Chagaskaya. The whole species seemed to have been affected. And without genetic mixing, harmful mutations might have accumulated and weakened the Neanderthals.
Many cases of endangered species, you still have many individuals, but genetically they carry such a deleterious load of harmful mutations that they prevent their survival long term. And this will be exactly the case with Neanderthals, probably.
In Siberia, the inbreeding was explained by isolation, but El Sindron was right in the heart of Neanderthal territory. It doesn't make sense, unless the Neanderthal population was much smaller than previously thought.
We can use genetic methods to reconstruct population size over time, and we actually see this in Neanderthals, that the population size as they expand into Europe was large, and then it falls off a cliff, and actually it stays very low for most of the time. And I think that is a good way of describing Neanderthal presence. There likely were surprisingly few people.
Genetics estimates the total number of Neanderthals at a maximum of 70,000 individuals scattered over an enormous territory of several million square kilometers. With such a sparse population, all it would take is the disappearance of a single clan to leave the neighboring clan isolated and forced to inbreed. And that's not the only problem. Silvana Kodemi's team also modeled a scenario of a slow demographic decline based on the theory of a very small but continuous decline in fertility.
We realized that if we changed the fertility of Neanderthal women just a tiny amount before the age of 18, we would end up with the disappearance of Neanderthals within 5,000 or 8,000 years. It wouldn't require a big difference in fertility. It could have been as little as 0.01%. And over 5,000 years, the consequences would have been catastrophic.
A decline in fertility isn't the only possible explanation for the disappearance of the Neanderthals. A very slight increase in infant mortality or health problems caused by inbreeding is also possible. In any case, it wouldn't take a disaster to wipe out an entire human species.
Small populations are fragile. If you take a Neanderthal community of 25 people, the death of a single woman of childbearing age could have a significant impact on the group. The less diverse the population, the greater the impact of any accident that might occur.
The disappearance of the Neanderthals appears to have been a very long demographic process that spanned tens of thousands of years and began long before the arrival of Homo sapiens in Europe. With a population that was already widely dispersed, the last Neanderthals might have simply ended up being assimilated by the newcomers.
We know that Neanderthals, for most of the time they were around, were really on the brink of extinction. If there's suddenly more modern humans around, they just might have become the more likely partner for Neanderthals to mate with other Neanderthals.
I think the idea of them becoming assimilated into populations of humans rather than becoming completely extinct is an interesting possibility that may be closer to reality than we thought before.
But why didn't we meet the same fate as Neanderthals? It wasn't just the Neanderthals who disappeared, but also all other human species. Why did we win the ruthless evolutionary race? The answer might be found in our very own Garden of Eden, the hospital environment where Homo sapiens evolved for hundreds of thousands of years, Africa.
Maybe just down to items of luck, being in the right place at the right time, not being subject to difficult changes in climate and environment in one part of the world, for example. Living in colder parts of the world means that your population is necessarily smaller than it is in other warmer parts of the world where the biomass is bigger. So I think perhaps for late humans coming out of Africa 50 to 60,000 years ago, they may have been coming from a population that was much bigger, and this larger population size, under the right climatic conditions that allowed them to spread and disperse much more widely than any other group had previously.
So it's just a stroke of luck that we're still on Earth? Maybe not, because Homo sapiens also had an asset of their own that can be found in their genetic diversity, which is somewhat more than the Neanderthals.
When we look at these first modern humans that we have, we don't see the extreme inbreeding we see in Neanderthals. They must have had some social mechanism of outbreeding, of meeting up with other groups. And I really think there's something about these larger social networks in the modern humans that might be the real answer.
Could the key to the mystery be found in sociability? To be sure, we'll take a look at the black box of Homo sapiens, the brain. At first glance, the Homo sapiens skull is very different from that of Neanderthals, which is what surprised archaeologists the most when the first fossils were discovered.
If you look at the head of a Neanderthal compared to that of a Homo sapiens, it's really very different. The head of a Homo sapiens is high and looks more like a soccer ball. The head of a Neanderthal is a deformed ball, more like a rugby ball.
Contrary to all expectations, the Neanderthal brain was also larger, at 1,600 cubic centimeters on average, as compared to 1,500 for Homo sapiens. But there's even more to it. Using casts of the inner surface of the skull, researchers were able to highlight a much more fundamental difference related to the internal structure of the brain.
Basically, our species has followed a path which is that of increasing performance without a particularly marked increase in size. For example, in our species, and for quite a long time now, we've seen the cerebellum, which is a rear part of the brain, developing more and more.
For a long time, it was believed that the cerebellum was only associated with motor coordination, but it actually seems to play a much larger role in our social behavior.
For example, it's known to be involved in reward circuits and social interactions. So it's not negligible to see this development of the cerebellum, especially in our species, more than in others.
As we've seen, social cohesion is essential for the survival of hunter-gatherers. Did Homo sapiens evolve to be more and more sociable? Another clue is a new phenomenon that appeared shortly before Homo sapiens colonized the world: the multiplication of ornaments made of shells, bones, and animal teeth.
In hunter-gatherer societies, these objects have a fairly strong social function. They identify, for example, individuals who have a certain social status within the group. So objects like these reflect greater social complexity.
With ornaments, we see the appearance of new social ties, which might have increased sociability within the clan, but also outside of it.
You know, Neanderthals use ornaments too, but the first sapiens, the first modern humans, use a bit more ornaments. That might be important for kind of delimiting groups, indicating you're belonging to a certain groups. And then it might also be useful in some kind of exchanges.
So during this period, we see an increased level of interaction, an increased level of perhaps exchange of these types of ornaments and artifacts that perhaps give benefits in terms of a wider group and a network of people across large distances.
By evolving in larger groups and weaving even wider social and commercial networks, Homo sapiens kept the risks of inbreeding and extinction at bay. With this exceptional capacity for socialization made possible by a peculiar evolution of our brain, perhaps we finally found the secret to our species' survival.
One of the characteristics of humans is our ability to create networks of solidarity. We stand in solidarity with people we don't know, even those who live very far away, but with whom we share a language, a religion, or values, all of which makes us feel like we belong to the same entity. This very human trait is probably one of the factors that explains, beyond technical progress, how we've managed to colonize the entire planet.
So our success might be a matter of numbers and social connections combined with a bit of luck. Neanderthals were also sociable, but perhaps a little less so than us.
Over the course of several thousand years, these small differences may have made a difference overall in terms of the success with which Homo sapiens were able to live, adapt, and prosper. But in evolution, it's the small differences that may have made a big effect.
Of all the life forms that inhabit the Earth, a single Homo sapiens is far from the most powerful. Cooperation and collective genius are its strengths, a reflection that resonates all the more today in the face of many challenges of tomorrow.